Okay, this is example 4 in our differential equations topic, and hopefully you've been with me through the first few examples, discovering what a differential equation is, and also the first few examples of our separating variables method. And what we're looking for here is this kind of shape of some y function dy by dx is equal to some function in x. So looking at this example here, it's a bit all over the place. We don't have that arrangement yet, so we can't separate the variables. What we do need to do is to take a common factor of the dy by dx terms. First of all, we'll have a look at what we've got. So there's dy by dx times x plus 1. Okay. Now, this minus 2 isn't any use. We don't have a sum of terms at all. It's all about a product of terms. So what we can do is we can take the 2 to the other side, or add 2 to both sides, and that y plus 2 becomes a fixed term in its own right. We're going to move that around together. So here we've nearly got it right, because we need the y function on the left and the x on the right. So we basically do a bit of algebraic maneuvering. The y plus 2 becomes 1 over y plus 2 on the left. X plus 1 becomes 1 over x plus 1 on the right, and we've got dy on the left, and we can write the dx on the right hand side, as we've been doing with the previous examples. That's us. We've got a function of y times dy by dx, or dy equals function x dx. We're ready to integrate, and as I said in the previous example, the main issue with this method is remembering all the different integration techniques. So we're looking at these ones here. We've got linear expressions on the denominator, which means we're going to introduce some natural logs. So the integral of 1 over y plus 2 is a natural log of y plus 2. And the integral of 1 over x plus 1 is a natural log of x plus 1. And we'll introduce a constant of integration here. It's not, of course, finished at the moment, because we want just an expression in terms of y. So to kind of undo these natural logs, we want to raise each of these sides with an exponent e. We'll take exponents of both sides. And on the left-hand side, that cancels out. We've got the e and the natural log are inverse operations, so we're left with y plus 2. And what we can do on the right-hand side, because we've got a sum of powers here, we've got the log of x plus 1 plus c. I'm actually going to use the rules of indices to split that up into e to the log x plus 1 multiplied by e to the power c. Okay, and because of that, e to the power log x plus 1, again they cancel out, and we've got x plus 1 multiplied by e to the c. Now, e to the c is a constant term. E is a particular fixed value, 2.71, so on, and c is a constant. So that expression will always be a constant term. So what we tend to do in this kind of topic is, rather than keep e to the c, we replace e to the power c with a capital letter A. It's just a multiplier to say, look, instead of our constant term, c is usually a term that's a constant that's added or subtracted. So because this is a multiplying constant, we tend to introduce a different letter to say that so far we're going to have a times x plus 1, and all we need to then do is remove the 2 from that side and say that our solution is y equals a times x plus 1 minus 2. It's still a general solution because our constant term is still there. It's in the form of the letter A this time instead of the letter C, but that's still our general solution. Okay, so again, different integration techniques and different ways in which we then rearrange in terms of y. Okay, again, keep working through these examples. We're going to get onto some particular solutions, but this is hopefully helping you understand the separating variables method.